Remember that white light from the sun is made up of all the wavelengths of colors in the visible spectrum. When we point the probe at the sun, the spectrophotometer shows full intensity of all wavelengths in the visible spectrum. You may also expect a white light bulb to emit all the colors in the visible spectrum. However, when we use the spectrophotometer, it shows that some wavelengths are not emitted as much as others. Here is that red ornament under sunlight. Now it is easier to see that the ornament does reflect red wavelengths of light. Compare how the ornament's reflected light is different under the white light bulb than when it is under the sun. This illustrates how the properties of light are not always consistent with what we see. Another example is when we mix colors of light on the surface of a table. The combined emissions from a green bulb and a red bulb look yellow. However, the probe does not show that yellow wavelengths of light are present. So why do we see yellow? You are probably familiar with how paint combines to form additional colors. The primary colors of red, yellow, and blue can be combined to create other colors, such as orange, green, and purple. This is called a subtractive model. However, when we mix light, it follows an additive model. The additive model is also called the RGB model because when we combine the primary light colors of red, green, and blue, it produces additional colors such as magenta, cyan, and yellow. We can use the RGB model to explain why combining red and green light appears yellow. You also investigated how light is transmitted through colored water. The spectrophotometer shines white light through the cuvette and measures the absorbance and transmission of the light when it passes through the liquid. You probably expected the yellow wavelengths to be transmitted, but with your knowledge of the RGB model, you should also understand why green and red wavelengths are also transmitted. What wavelengths are absorbed by the yellow water? Transmittance and absorbance have an inverse or opposite relationship. So the wavelengths that are absorbed are those that are not transmitted. In this case, blue and violet are absorbed.